Welcome once again, All India AIATS Test Series Medical 2019, and I am here to discuss the physics test number 5, code A and B, and the date of test is 6/1/2019. So let's start with the question number 1. Question number 1. A particle of mass m moves in the xy plane with constant velocity v along the straight line PQ as shown in the figure. Its angular momentum with respect to origin is theta is the angle between velocity and x-axis. So you know, if I go for the angular momentum, we need only two things. Number one, linear momentum and perpendicular distance. So as question says velocity along straight line PQ. So if I resolve this line, so we'll get the horizontal component of velocity v cos theta. If I draw a line along with the direction of b cos theta, then we can say this line is called line of motion. But I need to calculate angular momentum with respect to the origin O. So we need a perpendicular distance from the point O. So if I go for the perpendicular distance, then B is the perpendicular distance because this is the line of motion. So if I place the value, first I will write the linear momentum, that is mass into velocity mv cos theta. Another thing is perpendicular distance, so we'll get mv cos theta, and this is the angular momentum. So we can say my option number 3rd will be correct. So let's move on question number 2. In the question number 2, a uniform rod of length L and mass m is free to rotate about an axis passing through A and perpendicular to length of rod. The rod is released from rest as shown in the figure. The initial angular acceleration of the rod will be. So here question is asking to us the angular acceleration. So I am going to use the torque is equal to I alpha, and we know very well. So I need number one torque, how you will calculate. The question number 2 will come out how you will calculate the moment of inertia, and alpha is our requirement because question is asking to us initial angular acceleration of the rod will be. So if I make the free body diagram, so this is the center of mass of the rod, and you know the position of center of mass for the uniform rod is L by 2. So mg will act here, and if I resolve the component of this force, so this theta will be 60 because this 60 is given. So here you can write mg cos 60. If I draw a line along with the direction of mg cos theta, so this line is called line of action. Line of action, and this is the center of mass. Another component will be mg sin theta, but I am not interested to write that because I need to calculate torque. So if I use this relation, so first I will write the torque. Torque is calculated by force. Force is mg cos 60, and you need perpendicular distance. So you can see from point A this angle is 90, so I can say L by 2 be the perpendicular distance, and another requirement is moment of inertia, and moment of inertia of the rod about one end is 1 by 3 ml square into alpha. So when you will calculate mass will cancel out. The value of cos 60, this is 1 by 2. So by taking a small calculation, you will get g into 1 by 2 into 1 by 2 because this L square cancel with L. So I have 1 by 3 L into alpha. Finally, angular acceleration will be 3g upon 4L. this is our initial angular acceleration. So my option number 4 will be the right choice. So let's move on question number 3. In the question number 3, two persons A and B are standing at the two opposite ends of the plank of length 4 meter. As shown in the figure, plank is kept on a frictionless horizontal surface. Displacement of plank when A and B interchange their position on the plank. Mass A, B and plank are given. But by this question we can observe that there is no external force. If there is no external force, then position of the center of mass will not be changed. So first I would like to use the vector. So if I write the displacement of A with respect to the plank when it will move from left to right, because we can say this is our x-axis and this is our y-axis. If I take simple quadrant system, the total displacement is 4, so we can write here 4I cap. Similarly, if I go for the displacement of B with respect to the plank, so we'll write minus 4I cap, because B is going to move from right to left. And similarly, if I write the displacement of plank with respect to the ground, then what we will do? So if I make the diagram, suppose this is the initial position of the plank and position of A. Suppose this is my origin at O. So I will count all kind of separation and distances from the point O. And this is the initial position of B and this is the position of center of mass. So when they will interchange, so if I consider the new position of the plank just like this. As I said, there is no change in the position of center of mass and O is the initial position. If I consider the displacement of plank is x from the origin on the left hand side. So by this discussion, I can say, because finally B will be here and A will be here. So I can write minus xi cap because it is moving on left hand side of the O. So if I go the displacement of A with respect to the plank, we can write displacement of A with respect to the ground minus displacement of plank with respect to the ground. But I need to calculate this one. So we will write displacement of A with respect to the ground will be displacement of A with respect to the plank plus displacement of plank with respect to the ground. Now I am going to put the value. Displacement A with respect to the plank is 4I cap and displacement of plank with respect to ground is minus xi cap. So that will give you 4 minus xi cap, and this is the displacement of A with respect to the ground. This one. Similarly, if I use the same method, then we can write displacement of B with respect to the ground will write minus 4 minus xi cap on the same manner. Now, but I need to calculate displacement of center of mass with respect to the ground. If I use this formula, then what we will write? We'll see. Displacement of center of mass with respect to the ground. So I am writing in short CG. That is mass of A, displacement of A with respect to the ground plus mass of B, displacement of B with respect to the ground, and similarly mass of plank and displacement of plank with respect to the ground, divide by mass of A, mass of B, mass of plank. As you know very well, this is a simple formula for the calculation of center of mass. So for the further calculation, I need a board. So we'll see in the next. So we'll see. As I said, there is no external force. The change in position of the center of mass will be 0 The position of center of mass is not going to change. So we'll write 0. And I am going to put the value. Mass of A is 40. Displacement is, as I said, 4 minus x. Mass of B is 60 minus 4 minus x. The mass of plank is B and displacement is minus x. Divide by 40 plus 60 plus 20. So when you will solve this equation, you will get minus 2 upon 3 meter. So this is the final answer. So now I am going to take my options. So I can say my option number 2 will be the right choice. So let's move on. Question number 4. In the question number 4, 4 identical uniform thin rods, each of mass m and length L, are joined to a common point O as shown in the figure. Moment of inertia of the system about an axis passing through O and lying in the plane of rod is. So here you can see, before going to solve this question, I would like to remind you, if you have a rod just like this angle is theta and length of rod is L, mass is m. Then if you are looking to find the moment of inertia, then you know very well the moment of inertia is calculated by 1 by 3 ml square sine square theta. So if I use this concept, we can say this angle is 60, this is 60 because 30 is given, 60, 60. So this is a symmetrical diagram. So if I go for the total moment of inertia, we can write 4 times of moment of inertia of any one rod. ml square sine square theta will be 60. So when you will place the value, sine 60 is root 3 by 2. So when you will take square, 3 will cancel out. On solving, you will get ml square. So this is the final moment of inertia of the given system. So I can say my option number 2 will be the right choice. So let's move on. Question number 5. In the question number 5, a uniform thin spherical shell of mass m, radius r, rolls down without slipping. You have to be very careful. Over an inclined plane, an angle theta with the horizontal. The ratio of rotational kinetic energy to the total kinetic energy of the shell will be. If I write rotational kinetic energy, then formula will be half I omega square. And we know moment of inertia in terms of radius of gyration is nk square. K is the radius of gyration. And in the case of pure rolling, V is equal to R omega. So omega will be V by R. If I use this, so we will write 1 by 2 I is nk square and omega can be replaced V square by R square. So I can write half mv square into k square by R square. So this is the formula for the rotational kinetic energy. If I go for total energy means rotational kinetic energy and for translatory kinetic energy. So first I will write for translatory kinetic energy half mv square, and if I go for rotational kinetic energy, you know, as I told you, half mv square k square upon R square. So if I take half mv square as a common, we'll write 1 plus k square R square. So this is the total kinetic energy. Now the question will come, how you will calculate k square upon R square? Very simple, because you know this formula in terms of radius of gyration. In the question I have uniform thin spherical shell, and uniform thin spherical shell, the moment of inertia about center of mass will be 2 by 3 mr square, you know. And another thing in terms of radius of gyration, mk square. So if I compare these two equations, we'll get k square upon R square is equal to 2 by 3. For further, you can see the coefficient of mr square will be equal to the k square upon r square. So now I am going to use this value. And as per the question, I need to calculate kinetic energy for rotational and total kinetic energy ratio. So rotational kinetic energy, you know, half mv square k square upon r square, half mv square will cancel out. So you have only k square upon r square divided by 1 plus k square upon r square. If I place the value of k square upon r square, that is 2 by 3. So we'll write here 2 by 3 upon 1 plus 2 by 3. So when you will calculate, you will find 2 upon 5 only. So this is the required ratio. So now I can say my option number 1 will be the right choice. So let's move on question number 6.